Yeah, so I will talk about SQL today. I wanted to kind of my goal of this presentation is to provide some reasons and for why you might want to use it instead of active record in some projects or in at least in some small subset, or at least to maybe a takeaway would be to maybe look at active record a bit more critically, and like to see that there are like alternative tools. So my name is Janko Marohnić. You can find me as Janko on GitHub or Janko Marohnić on Twitter. I am Croatian that's currently living in Czech Republic. I like to evangelize Ruby of Rails libraries in my free time. I have a blog and have published gems. So one of my most popular gems is called Shrine, but I also wrote a lot of others. Professionally, I had more than 3 years experience of SQL in production. One was for a company called Clearbit, which is business intelligence service, and another one was a US-based agency called Theora. So a little bit about SQL. It was created in 2007 by Sharon Rosner. And just for comparison, Active Record and the rest of the Rails were released in 2004. But most of the vast majority of this time, it was maintained by Jeremy Evans, which is also a Ruby committer and an author of other popular libraries like Rhoda and Rodauth. SQL is similar to the Active Record gem in the sense that it also implements the active record design pattern. This is some other design patterns for database interactions are repository pattern or data mapper pattern. So yeah, this one is active record pattern, just like the active record gem. SQL also powers the SQL support for the ROM-RB gem. So anyone familiar with it it can be easier to work with ROM-RB. Just to show you that SQL is pretty similar to Active Record. This is some example code, and this is the equivalent SQL code. So it has a lot of similar components. So throughout the presentation, I will be comparing Active Record code to SQL code a lot. So these will be visual cues that Active Record will be in blue color and SQL will be in teal color. So let's start with library design, and more specifically about confident design. So this is some basic Active Record code which calls established connection, and it creates a model, and then it's then what you will see usually when you open a Rails console is this message when you retrieve a model that you need to call the connection method to establish a connection. And what's kind of strange is that we've called establish connection before. So it seems that this method does not in fact establish a connection, which is a bit misleading. And this is the method that's called internally by Rails. So in Rails applications, you don't call it manually. Rails calls it for you. But yeah, still just this is how you would call it in scripts. So when you call connection, then Active Record will show the columns or the table. So moving on, what Active Record does is that it automatically defines methods based on the columns for that table. But if you try now to ask Ruby if there are methods for the columns defined. It will say that there are not. And it turns out that active record defines these methods dynamically when the first instance of the model is instantiated. So for me, like, this is not great. It's not great to dynamically define methods at runtime. So this is not what I would call confident design when everything is happening lazily. In contrast to that, the SQL connect method will actually connect to the database. So this line will fail if you've misconfigured the connection settings. And also when you subclass from SQL model, which is the equivalent of active record base, SQL will immediately parse the schema and define the methods. So nothing will happen lazily. I also found SQL to be more explicit, which was oftentimes welcome. So a common active record code is to define some query in the controller, but oftentimes the query is not executed in the model. So you would have to call 2A or load to actually execute the query. But what happens is that the queries are often executed in the views, which is kind of like, it's not great controller and view separation, like, because the controller's responsibility is to retrieve data, and it can be misleading when measuring performance, that it's not clear where if the views are slow or if the database queries are slow. So I think that the reason why this happens often is that active record relations, they are caching the result of a query inside them. So a relation object has a concept of being loaded, so that it doesn't execute queries. So that if you retrieve records, it executes the query, but then if you retrieve it again, it returns the cached result. So it acts sort of, it combines both the relation, the query behavior, and also it behaves as an array. And I think that this encourages delaying when the queries are being executed. In contrast to that, SQL datasets, which are the equivalent of active record relations, they are immutable. So they will always execute the query if you call, for example, 2A multiple times, and they will have deterministic behavior. And in my opinion, this forces you to decide when you want to execute the query, and I think it encourages better separation of concerns. Another example is the associations in Active Record and in SQL. So Active Record has this sort of collection proxy object, which will be returned by has many associated methods, which can do a lot of different things. So you can you can provide additional query conditions, or you can retrieve the records, or you can add, update, or remove associated records. In contrast to that, SQL has two main methods for retrieving the associated record. So you either you retrieve an array, which actually executes a query, or you choose, okay, I want to retrieve a data set because I want to append future queries on it, and only execute it later. So it kind of forces you to decide which of the two things you want to do. And then the methods for managing associations are just defined as methods on the model instance. Another thing I want to touch about is layers in the design, or like layers of abstraction. So it's common that in active record, whenever you want to do something, you always do it through the active record base object. This is uh, this is sort of the entry point for any interaction of active record. Um, and this is sort of global state, and that's one of the reasons why it was a bit difficult to introduce multiple databases support in active record. I mean, it was done. The Eileen did an incredible job, but it wasn't easy, and there are still bugs related to global state. In contrast to that, the SQL Connect method, it returns a database object, and the database object is responsible for any database interaction which is not related to models. So it is like, it can be considered more low level, but it's something that's often used. So this is a layer that's completely separate from models, and it's easier to access. It's easier to do stuff, and the DB is just a naming convention for like assigning a database object a constant. So with this design, SQL trivially supports multiple databases, and it has been supporting it for many years before Active Record added support. So the way that it works, the way that it connects to models, is that if the SQL model is subclassed, then SQL will take the first connection, like the first database object that was created implicitly. But if you want, you can also explicitly specify the database object you want to use for some model. And this way you can also specify a model to be to represent a table from another database. So as I mentioned, models and database object is separate from models. And if we look at the query interface that is available through the models, the same query interface is available through the database object as well. So this allows you to work on the level of tables and not have to create a model each time you want to make a query. And this is useful, for example, for database views, where you might not want to create models for each database view you have. It's useful in migrations, because in migrations you're not supposed to use you're not supposed to use models, because if you want to retain backwards compatibility. And third, it's useful when interfacing with legacy systems, which might not conform to Rails naming associations of plural tables or lowercase columns. And for me, it's also interesting how SQL approaches dealing with complexity. So an ORM, it has loads of functionality that it needs to support, and it takes a bit different approach to managing this complexity. So if you look at the ancestors for an active record-based class, you'll notice that that it includes modules for every feature automatically. So it will include functionality that you will of course need everywhere, like associations or callbacks or dirty tracking, but it will also include behavior that you might need only rarely, such as secure tokens or optimistic locking. SQL, on the other hand, it provides only the essential behavior by default. And if you want to use any additional functionality, you do it by loading a plugin. So loading a plugin is essentially just including modules into SQL's core classes. So if I want dirty tracking, I can load a dirty plugin, or I can load serialization plugin for serialized columns, or I can load, if I want single table inheritance, I can do this as well. And this way, for example, I always minded about active record that the type column, that the column called type is not allowed by default, even though I'm really rarely using single table inheritance. So it's kind of nice with SQL that you can even include plugins only in modules that you need. So this is useful. And this, with this design, you are making SQL as complex as you want it to be. And as a result of this design, SQL is much lighter. Like it has much less code, loads much less code by default compared to Active Record. So let's move on to features now. That's probably the more interesting part. So for me, SQL has always been really great at SQL expressions, at building SQL expressions. So if we look at Active Record, so for simple queries, you can use, it has this nice hash-based syntax with symbols and hashes, which allows you to easily write more simpler queries. But whenever you need something that cannot easily be expressed this way, then you usually have to resort to SQL strings. And alternatively, if you want to really build queries in Ruby, you can use Arrow, which is Active Record's internal query builder, and it allows you to build much more advanced queries also in Ruby. But for me and for most other people, it's always been a question whether this is more readable than the raw SQL part, because it's not really like designed ergonomically, and so it's difficult to figure out the correct code. So SQL is similar to Active Record in the sense that it also supports hashes and symbols for simpler queries. But when you want something more advanced, it provides an builder for SQL expressions, which is, in my opinion, much more ergonomic since it uses operators and it's just is designed to be used really often. And so if this, for example, if this SQL is a bit verbose, then SQL also offers a DSL-like syntax, which is called virtual row blocks, which allows you to do the same things, but it relies on method missing to instantiate some things for you. So this is also an alternative, which is kind of pretty close to raw SQL. And what's cool about SQL's expression API is that it's supported everywhere in SQL. So for example, if I want to, I can use it, SQL expressions, when creating a partial unique index. In Active Record, I would have to pass an SQL string in where, but with SQL, I can use SQL expressions. And also similarly, if I want to create an index on an SQL expression, I can use SQL expressions, like the same syntax here as well, which can be convenient that it's supported everywhere. So compared to SQL, Active Record is definitely more verbose, where SQL's expression API is more streamlined, in my opinion. And RL is still considered internal API of Active Record, and you will not find it in documentation, and you will rarely find in even any code comments when you are looking at the source code. While in SQL's expression API is public API, which is well documented. So yeah, this is what I mentioned. It's the documentation difference, and also that it's in active record. I even found that, for example, the update all method in active record at some recently still didn't take RL queries, but in SQL you will find it supported everywhere. Another area where I find SQL pretty powerful is eager loading. So eager loading is a way to load associated records in the fewest queries possible. So the two main strategies for eager loading is either a separate select query, which means that first you retrieve the parent records, and then its IDs are retrieved, and you're using that to retrieve the associated records. Or the other is to make a join, which also allows for querying. So this is something that you of course don't do by yourself. This is the ORM does it for you, but it's important to decide which of these two strategies you want, because it can have different performance characteristics depending on the use case. In active record, eager loading methods are preload, which makes a query, and eager load, which makes a join, and includes, which is actually used most often. It makes a separate query by default, but if you use references, then it will make a join. What I don't find ideal about this naming is that for me it's impossible to remember which one does what. It's the name of the method does not convey whether it does a select or a join. In SQL, there are only two methods. So eager will make a separate select, and eager graph will make a left join. And the graph naming comes from the method called graph in SQL as well, which does a join, but saves everything in a unique identifier. So for me in SQL, I always knew which method does which kind of eager loading. What's also cool is that SQL supports adding additional conditions to the eager loaded association ad hoc. So for in active record, if you wanted to add more conditions to an eager loaded dataset, you would need to create a new association method, association declaration, which is not convenient, especially if you only need some conditions in a single place, or maybe if that condition is depending on variables that you have in that scope at this time. But SQL, it supports extending the dataset or the relation dynamically, like at runtime, which can be really convenient. It also has built-in support for limited eager loading, which, for example, let's say that we have an association that where a movie has like top 10 reviews, and we want to, for each movie, we want to retrieve top 10 its reviews, and like it's often people often think that just applying a limit here would solve it, but remember that you want to it will retrieve 10 records in total, but here you want to retrieve 10 records for each parent record. So SQL has support for that, and that it kind of uses some kind of cool SQL logic to make that happen, and it also supports multiple strategies which can perform differently depending on the use case. SQL also has a really good Postgres support. So it has extensions for querying for making JSON queries in Ruby, which can be really convenient because it's sometimes difficult to remember JSON operators in Postgres. It also supports cursors and streaming in Postgres, which can make for really for memory efficient way of retrieving records. It also supports copy, which is a way to import and export records in a text-based format such as CSV. This is known as the fastest way to import or export data. And it also supports countless other features that you might ever need. And a lot of them are not supported by Active Record out of the box. So let's talk now a bit about performance. And concretely model performance. Let's say that we want to retrieve 1,000 records in 1,000 articles which have some columns. So if we benchmark the execution time, we'll see that for Postgres, Active Record is about 2 times slower by default, and it's even and also that it allocates more objects by default, like almost 3 times as more objects. And actually, Active Record is still cheating here a bit, which we will see if we actually try to retrieve column values in both cases. In this case, the SQL execution time stayed the same, but Active Record execution time grew, and also the number of allocations grew. So it's roughly it can be 4 times slower in some cases, or it can allocate more than 4 times more objects. And the reason why there was this difference is that Active Record actually is lazy again in some work that it does on typecasting the column values, whereas SQL does all of the work of retrieving all of the values when you retrieve the record. And I think it's so basically Active Record optimizes for when you will not maybe need some columns. It will save some time, while SQL optimizes for when you will need all columns. And a difference is also, as I mentioned before, that SQL has much less code by default. So if we try to make an experiment where we load as much of SQL features as possible to match the situation of Active Record, this just loading all of the features will make the fetching 1.4 times slower. So this is just having the features available but not using them. And this is an illustration how more code is usually that more code will usually be slower than less code in this case. In SQL also, when it's important, when the performance is important, SQL allows you to break out of remove the model overhead. So if we call naked on the dataset, then it will retrieve pure hashes, which can really be useful in cases such as efficient CSV generation. And in one case, I had a script that I reduced its runtime 3 times by skipping the model overhead. And SQL also has there are also connection pool differences between Active Record and SQL. So a connection pool is a component that's basically it is managing connections in a way that it doesn't create a new connection on each query, but it caches them and reuses them. So let's look at this Active Record code, which which allocates a pool of maximum of 5 connections and creates 6 threads which execute the query. So what will happen here with active record is the five queries will execute just fine, but the 6th query will say that there are no available connections. And this is actually not ideal, considering that active record will wait 5 seconds for a connection to be available, and select one query is the fastest query possible. So the way to work around this in active record is to use the with connection block, and this is often recommended for Sidekick users, which forces active record to return the connection back to the pool after the query is executed. But this is not great. This is not a great solution because we shouldn't have to worry about connection pool or connection management. In SQL, the equivalent code will work just fine because SQL does not tie a connection to a specific thread. It releases connections back to the pool as soon as it doesn't need them. So in this case, SQL will execute all 6 queries just fine. Now, the important thing is how easy it would be to use SQL in a Rails application. So one option is when you already are using active record, is that it would be good to be able to, if you want to play with SQL, to be able to run it alongside active record without problems. So the main problem is that SQL will require using a separate database connection by default, which can make it impossible for active record or SQL code to be combined. But for this, there is I've created the SQL active record connection gem, which actually makes SQL reuse active records database connection, and it allows you to make basically the integration seamless, as seamless as possible. An alternative is to use SQL instead of active record if you are starting on a new project. So for this, you would use the SQL Rails gem, which provides all of the glue that one might be familiar with when working with active record, so that it's as smooth as possible. For integration with forms, you can load the active model plugin of SQL, which makes SQL models quack like active models, and this works with both the Rails form builder and for simple form. And also, it's if you're using SQL instead of active record, then you will have to replace some of the libraries that are tied to that are active record specific. But in many cases, there are pretty good alternatives that are that have SQL support. So to recap, SQL has like a much more layered design, where its database, dataset, and model classes are are pretty loosely coupled. It really nicely manages complexity with a plugin architecture. It has a really polished SQL expression builder. It has powerful eager loading capabilities, and it supports a lot of advanced Postgres features, since the author of the gem is the author of SQL is a fan of Postgres. And also it's by default much faster and lighter than active record, and also has a more reliable connection pool. And here are some links, and that's it from the presentation. Thank you.
Cool. Thank you, Janko.